We are going to talk about how to solve basic logarithmic expressions and equations. There's some things that you need to remember about logarithms. Remember that logarithms are only defined for positive real numbers. You must always check the domain of a logarithmic function before solving it, and then verify that your answer fits in the domain. So the log of v and the ln of v are only defined if v is positive. So in other words, you can't have the log of -2. Try putting that into your calculator, you're going to get an error message. You can't have the ln of -5. Try putting that in your calculator, you're going to get an error message. These are called arguments. Okay? The arguments of logarithms have got to be positive values. Okay? The graphs of log of x and ln of x both pass through the point 1, 0. You knew that. In general, the answer to a problem that looks like this is going to be k, and a problem that looks like this is also going to be k for every real number k. So let's talk about that. Okay, so let's say we had the log of 10 to the 4th, which fits into this category here. The log of 10 to the 4th is equal to y. Now, according to this y value should be equal to 4, right? If you have a log of 10 to the k, it should be equal to k. So the log of 10 to the 4th should be equal to 4. Well, let's see. Remember that the base of this logarithm is 10. If it's not written in, it's understood to be 10. If we rewrite it as an exponential, we get 10 to the y is equal to 10 to the 4th. 10 to the y is equal to 10 to the 4th. And then we know if our bases are equal, then the exponents must be equal. Therefore, y is equal to 4. So it holds true. Let's do a log that's not base 10. The log of 3 squared to the base 3. According to this formula, it should be equal to 2, the exponent. Well, again, let's rewrite it as an exponential. 3 to the y is equal to 3 squared, right? 3 to the y is equal to 3 squared. Bases are the same, exponents are the same. Y is equal to 2. All right, let's check out a natural log. Remember that the base of a natural log function is e, right? It's base e. That's not a great e. So rewrite it as an exponential. E to the y is equal to e to the 5th. E to the y is equal to e to the 5th. Bases are the same, exponents are the same. So y is equal to 5. Okay, so these 4 things you can figure out by doing what we did up here. And I kind of explained it here, so if you want to freeze the video and look at it, or pull up the Google Doc that I am attaching in Google Classroom, you can check it out. But basically, the log of 1 is 0, the log of 10 is 1, ln of 1 is 0, and the ln of e is 1. These two are going to reoccur over and over and over and over again next year in AP Calculus. So I highly recommend that you know those values. Okay, so I have 1, 2, 3, 4, 5, 6, I have 7 problems, 7, maybe 8 problems that I want to do with you, and then I'm going to set you free to do some on your own. So we're going to rewrite each of these logarithms as an exponential, and then we're going to solve it. So before we were rewriting and we weren't solving, but now we're going to solve. So I have to figure out what the log of 1,000 is equal to. I have no idea what it's equal to, so I'm going to call it, I'm going to give me a variable. I'm going to call it m. You could have picked x, you could have picked y, you could have picked a, doesn't really matter. So I'm going to rewrite it as an exponential. The base of this logarithm, since it's not written in, is a 10. So 10 to the mth power is equal to 1,000. Well, this takes us right back to our exponential equations that we did about a week and a half ago. Can I write these with the same base? Well, 1,000 can be rewritten as 10 to the 3rd. Once I get the bases the same, I know my exponents are the same. So this problem is equal to 3. Okay, remember, a logarithm is an exponent. This basically is asking, what can I raise 10 to, right? 10 to the what is equal to 1,000? And it's 3. All right, I'm going to skip number 2. Let's go to number 3. Again, all right, I'm going to call this one p this time. 10 raised to the p has to equal the square root of 10. Well, what does that square root mean? I can rewrite that as 10 to the 1/2 using rational exponents. So 10 to the p equals 10 to 1/2. P is equal to 1/2. Okay? So these are just very basic logarithm problems. I'm going to leave you guys to do 4 through 8. Let's take a look at number 9. Let's let this one equal a. Okay? Just switching it up a little bit here. So this is an ln problem. It's a natural log. Its base is e. Remember, it's not going to be written in there, but I know that it's e. So e to the a has to equal e to the negative 3. So therefore, a is equal to negative 3. Remember that e represents a number. It's like saying 2 to the a equals 2 to the negative 3. Let's jump on down to number 12 here. Again, it's a natural log. I don't know what it's equal to, so I'm going to call it r this time. So e to the r has to equal 1 over e to the 6th. So I'm going to have to do a little manipulating here. E to the r is equal to e to the negative 6, right? I bring it up from the bottom. That makes the exponent negative. So r is equal to negative 6. Okay, I only have a few more that I want to do with you. Number 13, again, it's a natural log. The base is e, so e to the 4th power is equal to x. And I don't have any idea what e to the 4th power is, so I'm going to go to my handy-dandy calculator. I'm going to remember how to get the e, right? It's the second and the ln button. That gives me e. I can put in the 4, and I get 54.598. So x is equal to 54.598. That is the answer. So you're going to need your calculator for some of these. Let's do number 16. What's the base here in this problem? If you said 10, you are correct. 10 to the 2nd power is equal to x. Therefore, x equals 100. Okay, 2 more problems. I might keep this under 7 minutes. Number 19. Base is 3. Exponent's 5, so 3 to the 5th equals x. Do you happen to remember what 3 to the 5th is? I believe it's 243. 3 to the 5th, yep, 240. Whoops, there it is, 243. So x is equal to 243. And then the last example I want to do with you is this one. Again, I don't know what these all had equal signs in them. This one doesn't have an equal sign, so I'm just going to let it equal an unknown. Let's call it x this time. So 3 to the x has to equal 3 to the 6th. Therefore, x is equal to 6. And that's it. And so all I want you to do with these logarithms, rewrite them as exponentials and then solve away. All right? Bye.